All right, today we are going to be talking about PowerShell in Azure Functions. My name is Joey, for those of you that don't know me. I am joined here by Dongbo, who has been doing the vast majority of the work on the PowerShell worker in Azure Functions, along with Tyler Leonhardt, who many of you know. So he's going to be helping me out with some demos in a little bit. Let's get right into it. Quick agenda. What is serverless? Who's familiar with serverless computing? Great. Awesome. I know there's been a couple great talks on that already so far, but we'll just go over a brief summary. What is Azure Functions specifically? What does PowerShell mean for Azure Functions v2? What's missing from today's public preview? Any caveats that you might want to be aware of as you're building out your first Azure Functions? We'll do a demo. We will talk about Functions 1.x versus 2.x. So a lot of you, any of you still using the Azure Functions 1.x experimental PowerShell support? Okay, yep, we'll be talking about that a little bit. We will give a little bit more info around what a cold start is, what that means, what happens when a cold start happens, and then we'll talk a little bit about the timeline for GA and a call to action for you guys to help out here with the effort and any questions that you might have, although I've got some questions for you as well as we figure out what the right thing to do here is in Azure Functions. So awesome. What's serverless? So we could bike shed for hours. We could sit in a room and everybody could talk about what they think serverless really means. But generally speaking, at a high level, there are a number of things that serverless typically entails. The big one is that you don't have to worry about infrastructure, right? So you're not hosting VMs. This isn't an infrastructure as a service thing. PaaS can be serverless. SaaS can be serverless. FaaS can be serverless. Those are platforms, software, and functions. Serverless is also typically stateless and short-lived. So because of that, you're not keeping all of your state stored within a VM. You're using serverless storage or queues or tables or what have you to keep your data in state. Typically, the scale is managed in serverless architectures, so you get this dynamic allocation of resources where more resources are available as you need them and less are available as you don't. Typically, this means you have a latency trade-off. So because the infrastructure is not always available, like I mentioned those cold starts before, sometimes you have to spin up a fresh run space in order to begin executing code. So there's sort of a latency versus dynamic allocation trade-off. Typically, these things are event-based. So there's some event that happens, whether that's a REST API getting hit or something happening in your Azure subscription or happening on a third-party service via a webhook that's going to trigger your code to run. And these are typically used to build microservice-based architectures. So because these things are short-lived, because they don't have state, you're usually compartmentalizing as much of a function as you can into a single, you're compartmentalizing into as many units as you can. So you're sort of decomposing your architecture into smaller pieces. And then often these are built on containers. So you'll see a lot of these sort of functions types services are more and more supporting Docker containers or supporting an export to a Kubernetes cluster or what have you. So Azure Functions is one of our serverless offerings. Many of the things that I just discussed are also applicable to functions. So functions are supposed to have a single responsibility. They do one thing. They only run somewhere between 5 to 10 minutes in most cases. And so you want to make sure that they're only doing one thing and doing that thing very well. If you need a longer scenario, you're going to chain these functions together. Again, they're short-lived, 5 to 10 minutes. These are stateless, so they don't rely on any kind of state. They're attaching themselves to storage, or they're getting some JSON input in order to do some work, and then emitting their state at the end as a return value. And then they're event-driven and scalable. So in the consumption model, you don't have to think about your VM scale at all. We're just going to spin up run spaces as you need them and spin them down as you don't. We do offer two other pricing models called Premium and App Service Plan, and those allow you to have more dependability on infrastructure being available, but they do cost more. So, all right, let's talk a little bit the Azure Functions programming model. So as we said, these are event-based. Azure Functions is really awesome in that it has all these event triggers built in. I won't get into them all right now, although we'll be showing a couple. But basically, you've got your HTTP webhook is the big one. So I hit a REST endpoint, that's going to call some code. But the other very popular one is just the timer trigger, which is simply, hey, I want to do something every 10 minutes or every 10 hours or 10 days or whatever. But we've got a bunch of integration with Azure services as well as some third-party services. And then there's a bunch of pre-baked functions in the serverless library that sort of interface with more of the third-party services that we don't have first class. Then you get to author the code in whatever language you want. So we've got C#, F#, Node, Java, Python, PowerShell. The cool thing here is that because these things are generally talking REST on the way in, REST JSON on the way in, REST JSON on the way out, I can mix and match languages across function apps. So I can't do multiple languages within a single function app, which is sort of a container around a set of functions, but I can have these function apps calling each other over REST because everything's just sort of a dumb REST pipe to some extent. And then at the end, I return some value. So we've got these things called output bindings. These allow you to emit that value to a number of places. Typically, you're just going to get a JSON object returned to you in text. But you can also emit some data to an Azure table, a storage queue, send an event grid notification, send an email, or any number of other output bindings. So PowerShell and Azure Functions, what can we do? Well, today we support Windows consumption dedicated and typo 1. Let's do it. Linux dedicated is not supported right now. So we experimented with Linux dedicated. We didn't feel confident enough to put it in the public preview. So today it's just Windows consumption dedicated and premium. It does use PowerShell core. So the V1 experimental model used Windows PowerShell. Azure Automation used Windows PowerShell. And again, typo number 2. I'm in trouble here. It's not -RC. I can see Tyler frantically shaking his head in the back. I cannot believe you left that out. So yeah, this is running 6.2.0 final now, so apologies there. But it is a fully native programming model as opposed to the V1 experimental. So this was not something where we're piping text in and out of files anymore. This is a fully native PowerShell object that you get as soon as you enter the function code, which makes your life much easier. You don't have to parse JSON. You don't have to sort of wrangle the object yourself back into text when you emit that output binding. We do support all of the triggers and bindings that are currently in 2.x. I will say that as we built these demos, I found some bugs in some of the templates that are a little on the lesser used side. But generally speaking, the triggers and bindings all work. It just sometimes takes a little massage from the template. Those are going to continue to get better though over time. And I've got all kinds of bugs I'm going to be filing next week for those templates. So. We also have support in the functions core tools. So this is the Func CLI. One of the things that we added as we were doing this work, the Func CLI in the past required Azure CLI in order to authenticate with your Azure subscription. We now have a fully supported workflow with just Azure PowerShell. So we actually detect whether you've done a login with Azure CLI versus Azure PowerShell. And even if you don't have the CLI, we'll pick up that login from Azure PowerShell. And you don't need to install that extra dependency. I personally have Azure CLI on all my machines, so it didn't really matter to me, but many of us are working in a purely PowerShell workflow. We also have MSI and service principal support. We recognize right now that the documentation is a little bit lacking in regards to adding the MSI token. There's a couple extra clicks you have to do to associate the identity with the token and with the function app. But once you've done all that, we basically have an automatic authentication that happens in the functions profile that's going to log you in from the MSI token. For those that don't know, MSI is the Managed Service Identity, which is a lot easier to manage than Service Principal, especially as you're doing the rotations of the keys and that sort of thing. But yeah, you basically get auto-authed into the function once you've set that up, and then you have access to a bunch of your Azure resources from within that function code. We also have support for something called managed dependencies. So today, this only supports the AZ modules. There's a little requirements.psd1 in there that says we're grabbing AZ1.star. And basically, the Azure Functions service is going to continue keeping that module up to date over time. In the future, we are going to support all the modules. We actually have an explicit block right now in the code to not do anything but AZ, and that's because we're still stress testing what happens if you go shove 50 module dependencies in there, and how is that going to affect your cold starts and that sort of thing. But the intent here is to really support arbitrary modules out of the gallery, and then eventually possibly even arbitrary modules out of arbitrary repositories. And so we're going to continue growing that support over time to make the management of your module dependencies a lot easier. Lastly, we have profile support. So we're going to talk a little bit more later in the talk about what a cold start is, but basically a profile starts with every cold start, and it basically is there to get your environment prepared for what your functions are going to be expecting as they begin to execute. We ship a default profile template that does that MSI-based authentication that I discussed earlier, we've got some extra stuff in there that you can uncomment that are some similar helpers. For instance, a lot of folks have written a ton of code already with the Azure RM modules, which have the old Azure RM commandlet names. So we have a commented line in there that you can uncomment to get the Azure RM aliases back, right? Enable Azure RM alias for the AZ module that gives you the old commandlet names, so you don't have to rewrite the bulk of your business logic if you're trying to migrate stuff into Azure Functions. So, super quick demo. This is an HTTP webhook. This is the one we're going to find out if this fails or not right now. So we go into function apps, and again, I would normally do this all from VS Code, but I did not have my laptop, and so I did not have the local code. So literally Portal broke, you're saying in the last half an hour you're getting repro? That's freaking awesome, man. We're going to try, because I'm wired in, I'm hoping that it's like maybe just the, so if I go function apps, demo gods, I've made them angry. So the interesting thing here is that had I written down the URL, I don't have the endpoint URL. Is it just, it's just the like message to teams? Yeah. We're gonna do it super live here.
Just replace this part with
yep.
message to teams.
So we've got that. Okay. So no SCM, and then .NET, and then /API/
The name is
send teams message. I think that was it. All right. Well,
Let's try it.
I think this is it. So this is some code that if I got to show it to you. Oh no, actually I can't show it to you because we've got it here in the app service editor, and it's send team message. There, it's team message. Excellent. Okay. So this is actually the code. This is this is like hidden behind a weird little button. This is called the app service editor. They just shipped this. It's Monaco based. It's way better than everything they've had before, and is really fast and actually way better for editing this stuff if you have to do it on the web like I'm stuck doing right now. So check out the app service editor. But in here we've got a couple things. So we've got a modules folder. I've done a save module of the PS Teams community module inside this folder locally before I did the deployment. And that ensures that that's going to be added to the PS module path for the function when it runs in this context. Then we've got our profile.ps1. This again is what I was showing before, or talking about before, where the MSI secret is automatically grabbed. You guys probably can't see this at all in the back, huh? No. Nope. And now it's telling me to reconnect. That's sweet. This is, we're having so much fun, guys. Woo! They are not happy. I'm on Ethernet right now, guys. This is sweet. Okay, so check this out. So we pass in this query parameter. You probably can't see this either here, but this says we're going to do this. Yay code. What we doing now, laptop? So this is the URL that I'm going to be pasting in. All right, so this is the name, message to teams is the name of my function app. The name of the function itself is send team message. And then I'm going to pass one query parameter, which is Dongbo. And I've got a pre-baked body in there. It's going to go to the PS Teams module. I've set up, the PS Teams module uses a tokenized webhook URI in order to authenticate with Teams and push to the right channel. I've stored that as an environment variable inside the app service editor. The app service itself. So you put all your secrets into a bucket that the app service instance picks up and then sends over an encrypted channel and sticks as an environment variable into your function so that you don't have to store your secrets in a JSON file or handle certificates or anything like that. So this is going to send a message to a channel. We're going to find out if just the management plane is down or if theoretically this should return something. And actually, oh, we've got Portal working now. Great. I think, yeah, I think that's happening right now. So we're just going to keep rocking on. I don't want to waste all of your guys' time looking at spinning loading bars, but this is definitely supposed to, send a message out to this Teams channel, and that would have been really cool. It would have said, "Hello, Dongbo. Welcome to PowerShell Summit. Hope you're having a fun time, everyone." But I'm going to go ahead and swap back over. If we get some time at the end, we'll come back and look at the code because I know that's really anything anybody wants to see. Yeah, apologize for that, guys. This is how it goes. I don't see that screen. Oh, there we go. So, what's not there was not there. Yes. So what do we not have yet, right? So one of those is Linux support. Again, we think that this will be coming down the pipeline. Right now, this is primarily supported for Python, but we'll add this as Linux support matures. There's also something called durable functions. Durable functions you can kind of think as conceptually similar to the way workflows work. So it's a concept inside of Azure Functions that allows you to save the state of a function call so that you can asynchronously. Let me rephrase that. It allows you to asynchronously call more Azure functions and then save the state of them to some kind of persistent storage. So if I've got some large orchestration that I want to do, I can asynchronously call, say, 5 functions that all are going to take their own 5 to 10 minutes, and then that sort of master function is going to keep calling itself until the return values of those subsequent functions are found in the persistent data store. That's a long-winded way to say you can like checkpoint your return values, basically. We think that this might be useful to people, but it's a lot of work, and we would like to understand, how people will want to use it in the future. So if there's longer running orchestration that you'd like to do, please come find me afterwards. We can talk about durable functions a little bit and find out if it actually meets your needs, because it's got a bunch of its own caveats, and as I said, it's very expensive for us to go and implement. So none of the things in these lists, I should say, are guaranteed to come in the future, but some of them will, and we're still kind of working out which ones right now. So. Support for Windows PowerShell. This is one that will not come in. We're not going to do a Windows PowerShell version of the functions worker. However, if you're running on Windows, it's perfectly fine to shell out to PowerShell.exe. So it is there in the sandbox. You are allowed to call it. And if you've got some modules that require it, you can get the sort of dead object back from PowerShell.exe as CLI.xml and actually continue using it in pipeline scenarios with PowerShell core. I will caveat that the Windows compatibility module does not work inside of this sandbox, specifically because that leverages WinRM implicit remoting, which is not something that you have access to within the functions runtime. So you do have to shell out to PowerShell.exe, but if you're running into problems here, please let us know, because we realistically should just be getting whatever modules you need working in PowerShell core. Also, this concept of live trigger or binding objects. So in C#, they're using a bunch of the well-defined Azure SDK types. So when they get a return object, it's very often a live object that I can operate on. So for instance, if I get a queue trigger, that queue trigger has some methods on it that I can actually execute to affect what's in that queue. All the other languages happen out of proc, which Dongbo is going to be getting into in a second with the architecture. But basically that means that by the time the trigger gets to PowerShell, it's a dead object. So there are some ways that we might be able to work around this if it's useful to people to have those live objects. I believe that there are some scenarios that are useful with Azure PowerShell, where when I get a live storage queue object, for instance, that has those methods on it for execution, I can do some fun stuff in Azure PowerShell with those. But there hasn't really been a hardline scenario from anyone yet, and this again is pretty expensive for us to go and implement. So would love to understand if people feel like dead, what are essentially PS custom objects full of properties that you get from the trigger, if that's enough, or if people really feel like that's keeping them from being able to do their job. Gallery integration, again, I talked about those managed dependencies before. We're technically integrated with the gallery when it comes to Azure PowerShell and making sure that stays up to date, but we don't have that generic gallery integration for whatever managed dependencies you want. That will be coming through very likely before we GA. So definitely keep your eyes peeled on that one. No, so this is specifically, and I'll actually just show this really quick, if I can. Nope. Nope, it's this one. Let's see if I can get in. Function apps, they're still not being enumerated. Sweet. So basically, there is a requirements.psd1, and then there is a modules folder. In that modules folder, you can ship whatever the heck you want, and that's going to be part of your PS module path. So for this demo for Teams, I did a save module of PS Teams, and that when I did a publish or a deploy, it zipped up everything in that whole giant function app folder and shipped it up. The requirements.psd1 it's just a manifest, and it just says, hey, AZ equals 1.star. And when the worker starts up, it's actually going to ask the gallery, hey, I need Azure 1.star. Like, do I have the latest one gallery? And so today, that only works for AZ. In the future, you'll be able to add whatever arbitrary PowerShell gallery modules you want to that manifest with an arbitrary version string, and the worker's going to make sure that stays up to date for you. But we were worried that if you went and added 20 modules there, worker startup might take 5 minutes, and then we've defeated the whole point. So that's what we're still working through right now. Awesome. And does anybody else have any questions? I know this is like a lot of information, so feel free to stop me, raise your hand at any time. Cool. Support for dollar returns. Does anybody know what this is? This is like sort of a helper if you've ever used Azure Functions. Great. If nobody knows, then nobody cares, and I'm going to keep moving. We also discovered this week that add type does not currently work. This is just a bug. I think we know how to fix it, which is that we just need to add some new files to the worker. Yes. Yeah, we will be totally honest. We discovered it like 4 hours ago. So add type's busted. We'll work it out. I think we know why, and hopefully we can figure out what the fix is. So one quick caveat that everyone should know when using Azure PowerShell, and this would be a lot more interesting, I think, if you were able to see the code that was in that Teams demo to know what's going on already. But the basic gist here is that Azure PowerShell executes things synchronously, right? So when I say, give me a new VM, Azure PowerShell says, okay, Azure, go give me a new VM, and then it sits and polls Azure and says, hey, Azure, is the VM ready? Is the VM ready? Is the VM ready? And it'll just sit there and block your session the whole time that's happening. So of course, Azure PowerShell did this nifty thing, and they added the -as job parameter, right? So you don't have to do the job management yourself. You say -as job, that creates a job object, and you're able to use your PowerShell session just like you wanted to before. The problem is that job is still doing that polling. So it's sitting in the background, still asking, hey, Azure, am I done? Am I done? Is the VM ready? And so when you do an Azure job in functions, it's probably not going to finish the job before the function is ready to finish, right? So if I say start a VM, Azure says, okay, great, I'm going to go start a VM. And then Azure PowerShell sits and asks if it's ready. And then the function has nothing else to do. So when it gets to the end, it says, all right, I'm all done. And maybe the run space continues with the job, maybe it doesn't. There's, functions offers no guarantee there past the 5-10 minute window. And so you're not really sure what's happened, right? So hold until the operation completes. Without the Azure job, it will block an Azure Functions webhook until the timeout. So we have a hack. This is a hack. We're going to fix this in the future. But the way you're supposed to do this now, you start the VM as a job. Maybe you do a stop. You do some synchronous stuff as job. And then before you get to the end of the function, sleep for 30 seconds. Maybe 10. Some people say 10's fine. 20's probably fine. But the point here is that the job goes off, and it says, Azure, start creating the VM, or start starting the VM. As long as Azure receives that request and processes it, you don't actually need to know within the function whether or not the VM eventually started, right? So we can put some information on a queue. We can go back and pull that queue later. Dongbo's going to be going right into this. But basically, that 30 seconds is just long enough to make sure that the job has time to tell Azure what it wants to do. But it's never going to go long enough to get that return back to know that that was successful. You'll need to handle that in another function. In the future, we're working with Azure PowerShell. They're going to add a new parameter, probably something like ARM only or deploy only, and that's just going to do the deployment, not poll Azure to find out whether it's done, but rather just return to you a deployment ID that you can go and check on later. So that's really the way we want it to work, but today, if you're doing stuff in Azure, you need to know about this hack. So, Dongbo, let's turn my mic off and get you going, man.
Yep. So,
do you want to just take this one?
no, it's fine. I'm gonna use this one. Can you
All right, yes.
Sorry.
So that's HDMI, and this is Ethernet.
Yep. I don't need to take that. Sorry for the function service issue. I was planning to show this demo, but it seems like it's not working anymore. It's still working like a minute ago, even though the web page doesn't show the function at all. So I'm gonna show the code only. It's a simple management function app for starting the VM. So I have 4 functions here. The query, if you look at it, it's an HTTP trigger function. It will just query for all the power states of the VMs under this specific resource group, and reply back the status of it. For example, I'm showing here, I run it before. It shows that I have 3 VMs, and 2 of them are stopped, 1 is running. And then I have this VM stack queue. So if I want to start a VM, I just call this method. This function. This is a HTTP trigger function, but it has 2 output bindings. Let me show you. It's HTTP trigger functions, but it have a HTTP out binding and also have a queue out binding. So what it does is actually receive the VM name to be started and check the status of it. If it's already started, then just return without doing anything else. If it's not, it's gonna push a work item, which is actually the VM name, into the queue. The queue's name is VM start queue. And then this queue item will trigger another function to run, which is the VM start action. Let's take a look at it. So it's a queue trigger. Here it is, sorry. It's a queue trigger function, and that does not do any output bindings. So what it does is that it's take the VM name, it's gonna start it, just like what Joey showed you. I'm gonna sleep for 10 seconds, And then I'm gonna push a queue message to another queue called check queue with a visibility delay of 10 seconds. So it's gonna be awesome if we can support a queue out binding with a visibility delay, which actually, it means, okay, I'm gonna push a message to the queue, but the message won't show up in the queue immediately. It will show up after this 10 seconds. Today in the Azure Functions, only the .NET functions is able to do it because F# and C# script are running in the same process of the function host. They are able to do this, but for all other languages, they are running the separate worker process, and there's no support from the runtime layer yet to support this visibility delay setting for this queue item, for the queue message. So what I'm doing here is that I have a simple wrapper helper module, which is, I'm gonna use this get Azure queue storage queue from the Azure PowerShell module, get back the queue, and then call this method on it, add message, with this time span, which defines the visibility delay. Well, you're gonna see this. It's kind of awkward, this type. When I was doing this demo, working on this demo, I find that the same type here, the same type name, is actually defined in two different assemblies in the Azure PowerShell module. One is storage QDL, one is the Microsoft Azure storage.dll. And the Azure account module actually depends on the Azure storage.dll, and the queue, like the Azure storage module, depends on this DLL. So it make PowerShell confused to, like, it doesn't know which type you're actually asking for. It's gonna find the first one and return back to you, but it turned out the type it returned is from the different DLL, and when you're constructing this message and pass it to this method, you're gonna fail because this method is expecting the type from another DLL. So it's kind of awkward. We will file an issue later, but you have a workaround, which is to give the fully codified name for the type, including the assembly name. So let's go back to the action.
Do you want to run this one locally, Dongbo?
I can, but I never run it locally. Oh, it's still gonna depends on the services in because we have a SendGrid, and
It might not be down though.
let me finish this.
Can you just F5 and pray?
Sure. Okay, let me finish this first. So what the VM start action does is that start it and queue another message into a different queue with a visibility timeout, which means that the message will show up in 10 seconds. And then in 10 seconds, it's gonna trigger another function run, which is status query, it's the status report. And if you look at the status report, it's a queue trigger function, and its output binding is a SendGrid. It allows you to send an email. So in our report,
Has anybody used SendGrid before? It's
Yep.
like Twilio's email service. It's actually pretty sweet. We set it up in like half an hour.
yep. So in the status report, you're gonna check for the status of the VM, and if it's finally start up, you're gonna send this email using the SendGrid out binding. If it's still like in the starting up process, then it's gonna queue another message onto the same queue so that it's gonna check back in another 10 seconds. So okay, let me try to run it locally. Let's see if nope, this is not coming back. Sorry. So I can show you what's gonna happen once I try to restart the machine. Eventually, it's gonna come back and send me a message like this. Eventually, after the VM startup. So sorry that I cannot show it live.
Worked hundreds of times.
Yeah. You can see all the messages I received.
Check, check. So, we're okay. We're okay.
Sorry about this.
Everything. Hopefully, we'll check that. Sorry, guys. Scott, it was a mic drop. Yes, that was a mic drop. That's awesome. So yeah, I officially I can't even authenticate into the portal right now. I'm completely broken. So that's awesome. And Tyler was pinging me as I was off stage here, asking why we couldn't run these locally. And the problem is that they're all dependent on API keys that are stored up in the cloud because we don't want to put them in text files on the local machine. So none of it works. It's just great. It's great. So we'll try to get the demo code up online. Give you guys some ability to clone that thing and repro this yourself. They are very cool. I mean, the ability to emit to SendGrid or to Teams message. The other aspect of my demo is really that I'm using a really awesome module that someone out there in the community did for PowerShell Teams messages that if you guys haven't used yet, PS Teams lets you just send some messages on. Pretty cool stuff. I think there's a PS Slack out there too that does the same. I know Brandon's in here. He's probably got 5 different ways to send a Slack message in PowerShell. So just going through this real quick. So this is basically the differential between the two old or the old and the new architecture of the 1.x. Dongbo alluded to this. I'm gonna kind of gloss over this because we're running low on time. But basically everything was net framework based in v1. And the host and worker were on the same process, which allowed them to share more of that sort of live objects. Because we're going over this inter-process boundary between the language worker and the .NET Core-based host over on v2, we have to do a serialization to JSON before PowerShell gets it. The reason that that's not applicable for .NET is because they're actually running the .NET worker from within the same process. They kind of cheated a little bit, but it means that they get all kinds of awesome features there. It's just that we were not able to do the same for resource reasons. 2.x does have way more of a triggers and bindings, so we support a lot more stuff right out of the box. And I highly encourage you, if you're interested at all, to check out this awesome deep dive that Dongbo wrote on the V2 architecture for PowerShell. Really anything you'd ever want to know about how we implemented it and how the serialization is happening and every step of the run space initialization and pooling, it's all in there. So definitely check that out. So real quick, cold starts. What are they? Basically, cold start is when we don't have a run space ready to go. And a warm start is when you've already executed one and it's hanging around. We clear the variable table out, but we don't do anything else to the state of the run space, and we reuse it for your function app. There was some question in Kirk's talk earlier this week about whether or not we're reusing run spaces between tenants. No, we're not reusing run spaces between tenants. You definitely get your own run spaces for your own function app, and we determine whether to do a cold start or a warm start based on whether something's been executed in your function app. Cold starts take a lot longer. What are they, like 10 to 20 seconds, Dongbo?
It might be more if you turn on this.
Here,
It might be more if you turn on this dependency management feature because it takes some time to download the AZ module. So yeah, basically maybe 30 seconds sometimes. Yeah, maybe sometimes even more.
No, you're good. We're working to get that one down. Like, we recognize that that's too high. But there are some strategies for keeping them warm. As I said in this first one here, the longer between function invocations, the more likely you're going to hit a cold start. Now, the flip side of that is the more often you're executing, the more likely you're not going to hit a cold start. So while it's not officially supported, and there's no guarantee it's going to continue working in the future, I will not pretend that it isn't kind of common knowledge already across blogs that if you run a timer trigger that does nothing every 5 minutes, 10 minutes, it's going to keep your function app warm. So that's this thing a lot of people are doing. I will say, Don't depend on that for production. Like if you need it right now, you can go and play with it that way. But that may be relinquished in some way at some point in the future. So, but today it does work, and I know a lot of people out there are recommending that. So. Now, what happens when a cold start happens? Again, I think if you really want to know this stuff, you should check out that V2 deep dive. But basically, the host is running, a request comes in, we instantiate that worker process in that box number 2 on the right. We set the PS module path up with that local modules folder. We create a run space pool, and we instantiate the first run space. If you've got managed dependencies turned on, we asynchronously go out and check for, check the gallery to make sure you've got all your dependencies. Download them if you don't. Then we take that serialized trigger object, so that JSON property bag full of stuff, we turn it into a PS object and it gets handed to the worker process. Then we initialize your profile.ps1, so we do your authentication as soon as that managed dependency check is finished, because you can depend on the managed dependencies in your profile, so that's why that ordering works that way. And then we execute your function code.
Joey,
Yep.
can you talk for a second about why would I use managed dependencies versus having everything in that module folder?
Yeah, so the question is, why would I use managed dependencies versus just putting everything in that managed or that modules folder? So one of the reasons is you can give a version string that's going to keep you up to date on minor versions without having to go into a redeployment yourself. So the next time it executes, if there's a new version of AZ and you've got 1.star, we're going to pick up that new version of 1.star without you having to go and put it in the save module. The other problem that I've experienced a lot is that it's really frustrating when you want to do, you say you've done an install module of foo on your box, and then you want to ship foo up to your function app. Well, I'm doing local authoring and debugging. I've got foo in my PS module path, but that local modules folder for the function app is not part of my local PS module path. So now I'm doing a save module into that folder, and I'm trying to keep that in sync with what I have in my system-wide PS module path. So one of the things that we did with requirements.psd1 is that we mirrored some of the syntax of PS depends, which is a popular module that I believe Warren did for managing local module dependencies. So if you use PS depends, you can point it at that requirements.psd1 that gets used by the managed dependencies, and all those modules will get updated in the same way on your own local machine. We haven't totally tied ourselves to PS depends yet, and we're going to look at how much more of that requirements.psd1 we're going to fill out. But that was the intent of us going down that design path. Cool. We're definitely low on time here. All right, PowerShell and Functions v1. It's going away. It's never going to be supported. It's not native. We don't like it. Used files and strings. If you're using this today, don't. Use v2. Cool. We're going next. Timeline. We ship public preview on Monday. Woohoo! Azure Friday happened on Friday. Check out, Eamon did one with Scott Hanselman. That's fantastic. GA. The more feedback we get, the sooner it's going to be. Even if that feedback is, Joey, it's perfect, ship it. I want to hear that, because then we go and talk to our management, and we go, they said it's perfect, we're ready to ship it. Deprecation removal probably happened, of 1.x, probably happened sometime after GA, but TBD right now. That's it on the timeline. I know people are snagging pictures and stuff, so yep, soon, hopefully. Call to action. Please, 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 convert your functions v1 to v2. File issues. We've got everything in open source already. All this, I think shout out to Kirk Monroe and a couple other people who found this repo before we had even shipped a private preview and was giving us actionable feedback on our programming model. Serverlesslibrary.net is kind of like the PowerShell gallery, but it's a bunch of pre-baked functions. They're going to be adding PowerShell as a supported language to that thing. They told me possibly by the end of my talk, but it's probably going to be more like early next week. But definitely check that out. Some possible ideas that have been floated for stuff we'd love for people to contribute. If a VM gets deleted, remove it from monitoring. If we create a resource group, look up the cost center and tag that with some number. If a SQL server gets created, add some AD groups to give it access. If a VM, that should say CPU, spikes above 90%, send a Teams message to the on-call channel. If our storage latency goes over 50%, open a GitHub issue. Certificates are expiring in some number of days. Send an email notification to the people responsible. These are all things you can do, honestly, in probably less than an hour in functions. It's dead easy. So I know everybody has this kind of stuff. Try functions out. It's really like, it really takes the implementation time down. Cool. So a couple questions I have for you really quick. Who's already using it? You're awesome. How's the performance? Thumbs up, thumbs down. Thumbs up. I'm seeing some thumbs up. We're seeing a thumbs in the middle. Fred's a hard critic. I'm good. Yop is a hard critic. That's good. I want to hear that. That's great. We definitely think the performance has room for improvement. Programming model, thumbs up, thumbs down. Somewhere in the middle. Thumbs up, thumbs middle. We got, what are we missing here? Yes, so the comment was, hey, I like putting all my functions inside of a module. They make it a lot more testable with Pester, et cetera. One of the things that we do support that maybe isn't as well documented as it should be is an entry point. So you can actually specify, instead of the run.ps1, which is the default, you can specify the PSM1 as the thing you want to execute, and then the entry point is actually the name of the function inside that PSM1, and we'll execute that as if it's the run.ps1. And so there is some stuff you can do there, but we should talk after for sure. Does anyone care about the OS? Raise your hand. Sweet. What if I told you that Linux was faster? Would you care about it then? Okay. All right. It's not right now, so that's what. Yeah. Okay. What's an acceptable cold start? Like less than 10 seconds? Is that okay? Cool. Who needs like less than 5 seconds? Great. You guys are really making my job easy here. Warm starts are like 250 milliseconds right now. Yeah. Yeah. So those are hopefully fast enough.
Depending on the service plan you get, is there any guarantee of warm starts always?
Yeah, so the question is, depending on the service plan, is there ever a guarantee of a warm start? If you pay for an app service plan, that means you have an app service VM running all the time. That means that there's always a warm start because you're paying for that VM to run. You're not paying for the execution. We offer a model called Premium. Premium is like the app service plan. We only mandate that you have one VM running at a time, and then we do auto scale up and scale down for you of new app service instances, depending on how many requests you're getting. But it allows you to run a lot heavier VM than the current consumption model, which limits you to like a single core 2 GB RAM VM or something like that. Is there any modules that people want to shout out that they need in PowerShell core, given that we don't have Windows PowerShell and functions, that you have to have in order to use functions? PNP? Like Office PNP? Okay, definitely. Glad to hear that. Any others? You guys are awesome. Well, with that, thank you. I appreciate all of your patience. I'm assuming that this Azure service outage is going to end probably in the next 3 minutes. So if anybody does want to talk about the code afterwards, we can hop in and look at that just outside. I hope everyone had a phenomenal summit. I really appreciate everyone sticking around for a final session. Have a great flight home, and we will see you next year.